In maths, now we would be starting with the basic and the most important chapter of algebra, which is quadratic equations. Our first question says, if alpha and beta are the roots of equation x square minus px minus p minus c equals 0, then we need to show that alpha plus 1 into beta plus 1 equals 1 minus c, and hence we would need to show that alpha plus 1 whole square upon alpha square plus 2 alpha plus c, and this term equals 1. Our first part of the question is a pretty simple part. We just need to show that alpha plus 1 into beta plus 1, which will be equal to alpha beta plus beta plus 1. We need to find the value of this term. Now we know that alpha beta equals product of the roots, which is equal to minus p minus c. Alpha plus beta is equal to sum of the roots, which is equal to plus p and plus 1. So this p and p gets cancelled out, and hence we get the value of alpha plus 1 into beta plus 1 as 1 minus c, which we needed to prove. Now our second part of the question says alpha square plus 2 alpha plus 1, which we can write as alpha plus 1 whole square upon, now we can convert this also as alpha plus 1 whole square. Since we have added an extra 1, so we subtract a 1 plus c plus this is also equal to beta plus 1 whole square. This also we can convert into beta plus 1 whole square, and since we have added this extra 1, we subtract a 1 to leave the expression as this. Now we know from the first part that the value of 1 minus c is equal to alpha plus 1 into beta plus 1. So we substitute the value of c minus 1 over here to get alpha plus 1 whole square upon alpha plus 1 whole square minus alpha plus 1 beta plus 1, and also over here beta plus 1 whole square upon beta plus 1 whole square minus of alpha plus 1 beta plus 1. Now cancelling the common term from both the terms, we get alpha plus 1 upon alpha minus beta plus beta plus 1 upon beta minus alpha. Now this becomes alpha plus 1 upon alpha minus beta minus of beta plus 1 upon alpha minus beta, which becomes alpha minus beta upon alpha minus beta, that is equal to 1, which we needed to prove. So this is our final answer for the second part, and the first part was the proof which we proved earlier.